Welcome back, dear students. In today's session we will start exercise 10.5 of circles. So in the last session we discussed few important theorems. Now in today's session we are going to see how we can use those theorems to solve different questions. We'll see how to apply those theorems to solve different questions. So here for your reference I have given the theorem which we proved in the last session. This was the theorem. So I explained you this theorem in the last session, which says that angle subtended by an arc at the center is double the angle subtended by it in the remaining part of the circle. So let me again explain you this in short. So I said you in the last session that angle subtended means angle made by an arc at the center. Suppose if this arc makes an angle something at the center like 90 degree, then the angle made by this same arc in the remaining part of the circle will be half of this. Okay, this will be 45 degrees. If this is 90, this will be 45. Okay, this angle will always be double of this angle, or I can say this angle is always half of this angle. Okay, so we'll apply this concept. You can see the same question here, question number 1 of exercise 10.5. In the figure it is given that ABC are 3 points on a circle with center O. These are the 3 points, and BOC is given here, that BOC is 30 degrees. This angle is given to us as 30 degrees, and AOB is given as 60 degrees. If D is a point on the circle other than arc ABC, we have to find the measure of ADC. So in short, just to rotate this figure which I have drawn here, it looks same like this only. Okay, so first I'll find the angle made by this arc AC at the center. The complete angle is 60 plus 30, isn't it? That is 90 degrees. So first we'll find that angle. AOC is equals to, this AOC is equals to AOB plus BOC. Okay, so that is 60 plus 30, that is 90 degrees. Now according to this theorem, you can write the statement of the theorem. According to this theorem, this angle will be half of this angle. Okay, so I can write ADC, AOC is twice of ADC, so AOC is 90 degrees. Okay, so ADC will be 90 by 2, that will be 45 degrees. Got it, everyone? This is very simple and very important theorem. Let's continue with the second question now. In the second question, it's given that a chord of a circle is equal to the radius of the circle. Chord, which is the chord in this there are 3 chords. You can see the AB is a chord here. First chord we'll take. This chord is equal to radius of circle. So this is equal to this and this. These 2 are radii, AO and BO, and this chord. All 3 are equal. So chord of a circle is equal to the radius of a circle. Find the angle subtended by the chord at a point on the minor arc and also at a point on the major arc. So we have to find the angle subtended by this chord in the major segment as well as in the minor segment. Okay, so let's see how to find those angles. So given is a circle with chord AB. AB is equal to radius. Let point C be a point on the minor arc and point D be a point on the major arc. Okay, we have to find angle subtended by a chord at a point on the minor arc, means we have to find the green colored angle and we have to find this color. Okay, this both the angles we have to find in this question. Here no measurement is given. Okay, measurement of any angle is not given here. So we'll join construction, we'll join O to A and O to B. Now comes the explanation. So as AB, AO and BO, all these sides are equal, which triangle this will be? This will be an equilateral triangle. AOB will be an equilateral triangle, and you learn in triangles chapter that each angle of an equilateral triangle is how much? In an equilateral triangle, each angle is 60 degrees. Okay, so I can say this each angle is 60 degrees. this is 60 degrees I can say here. Okay, so AOB is 60 degrees. You can see in the next, again one more figure I have drawn for your reference. This is 60 degrees. So by applying the theorem which we studied in the last session, again I discussed it. So just imagine if this angle is 60 degrees. Okay, this was 90, I took 90 here. If I take 60 here, then what will be this angle? This will be 30 or not? Obviously it will be 30 degrees. So we'll use the same theorem here again and find the missing angle. So you can say this is 60, you can see here this is 60 degrees. So AOB, angle AOB is twice of ADB by theorem. So AOB is 60 degrees. So ADB will be half of 60, that is 30 degrees. Okay, this is 30 degrees. So we got one of the angle. Now we have to find this angle. How will be this 150 degrees? Let's see that now in the next step. Now in ADBC forms a cyclic quadrilateral. Okay, what do you mean by cyclic quadrilateral? A quadrilateral whose vertices lie on a circle. So there is one property of cyclic quadrilateral. Let me explain you that property first here. If you have a circle and a quadrilateral inside a circle, okay, any quadrilateral inside a circle, I need to change the color here. Imagine there is a quadrilateral inside a circle which touches, this quadrilateral touches the vertices of a quadrilateral lies on a circle. So this type of quadrilateral is called cyclic quadrilateral. Which quadrilateral is this? This is a cyclic quadrilateral. Cyclic quadrilateral. Quadrilateral whose vertices lie on a circle is a cyclic quadrilateral. There is one property of cyclic quadrilateral. In every cyclic quadrilateral, sum of the opposite angles will be always equal to 180 degrees. So I can say angle A plus C is equal to 180 here, and I can also say B plus D is also equal to 180 degrees. Okay, this is the property of a cyclic quadrilateral. So applying this property here, even this is a cyclic quadrilateral. You can see ADBC, this is also a cyclic quadrilateral. So when this angle is 30 degrees, how much will be this? Because these two are supplementary, they add up to 180. So this will be 150 degrees or not? Yes, it will be 150 degrees. So we can use this property here. You can see ADBC forms a cyclic quadrilateral. Sum of those opposite angles is 180. So we already have one angle there. So ACB, the other angle will be 180 minus 30. That will be 150 degrees. Very simple. If you know the rules, you can easily do these theorems. Okay, so these are all things. Then exercise 10.5, question number 3, you have to try on your own. Okay, I have solved it for you here. You can try all this third question on your own. Okay, thank you.